A rocket initially at rest on the ground lifts off vertically with a constant acceleration of 2 times 10 to the 1 meters per second squared. How long will it take the rocket to reach an altitude of 9 times 10 to the 3 meters? Okay, so we know that the rocket is initially at rest, so its initial velocity will be 0 meters per second. We know the acceleration is constant and positive in the upwards direction. And it is 2 times 10 to the 1 meters per second squared. We want to know how long it will take, so we want to know the time that it will take for the rocket to reach an altitude, or in other words, a positive displacement of 9 times 10 to the 3 meters. So we can use this equation. Displacement is equal to initial velocity times time, plus 1/2 acceleration times time squared. Initial velocity is 0, so we'll have displacement equals 1/2 acceleration times time squared. Multiply both sides by 2 over acceleration to get rid of this half and this acceleration here. So we have t squared on its own. We'll have 2 times displacement over acceleration is equal to time squared, or t squared. Now we have values for displacement and acceleration, so we'll plug those in. We have 2 times our displacement of 9 times 10 to the 3 meters, and that'll be divided by our acceleration of 2 times 10 to the 1 meters per second squared. Meter units will cancel, second squared units will come into the numerator, which makes sense. Time squared should be in units of seconds squared. If you evaluate this using your calculator, you should find that it's equal to 900 seconds squared. Keep in mind that we should have 2 significant figures here, so I'll implement those after we get our final answer. So if we take the square root of 900 seconds squared, we should end up with 30 seconds. And again, like I said, we should have 2 significant figures, so we can achieve that by either writing 30 with a decimal point seconds, or scientific notation, 3.0 times 10 to the 1 seconds. So this is the answer for this problem.